Yeah, good afternoon, everyone. The title of my presentation is Evaluation of Quality and Role of QA Test Engineers. Though it sounds very boring, but it is in the context of the theme of the conference, which is artificial intelligence, machine learning, IoT, big data, and stuff. So please pardon my Thunderbolt port of my MacBook is a little loose, so it might go on and off. But here's my introduction. So it's already been done by our friend. Right. So when I was approached for this presentation to give this talk, so I was curious about the theme. So the theme is, everything artificial intelligence, machine learning, newer set of technologies. So I thought, okay, let me go back and check what were the past PSTC themes. So I found these were the past PSTC themes. And one thing which you notice is in this year's conference, neither testing nor assurance shows up in the theme. So the theme is connecting all these technologies together, and testing or assurance or quality is missing in the theme. But this is an indication of the implications of new set of technologies for we as testers or the testing community, and hopefully by end of my talk, I'll be able to throw some light on it. So this is the agenda of today's talk that I'm going to give. So first we'll go over the artificial intelligence overview. We'll look at some of the terminologies that you might have heard, artificial intelligence, deep learning, machine learning, and we'll compare it with the conventional systems. Then I'll present a challenge of testing intelligent systems. Then we'll go briefly over the meaning of software quality and testability, just to brush up on our basics. Then I'll make some claim about testing of non-functional attributes. Then we'll look at the difference between testing intelligent versus conventional systems. And finally, I'll talk about, sum it up, okay, how QA or test engineers can evolve and contribute in testing intelligent systems. And finally, the last bullet is about intelligent testing, but my previous speaker has quite well covered it as an offering from her company. So artificial intelligence is already here. So these are some of the examples of where we see artificial intelligence or machine intelligence which is at play, and we are already using it in our day-to-day lives. So so in my introduction he mentioned that I'm part of pre-sales team in Synergip, and I contributed from the offshore. I'm already seeing there is an increase in the amount of queries that prospects are coming to us and asking us to build intelligent systems like recommendation systems or chatbots. For example, there is an apparel PLM company who approached us. Can you, intelligently categorize apparels based on their pictures? For example, whether it's a trouser or it's a shirt or it's some other kind of garment. Then there is a mutual fund platform which wants to recommend mutual funds based on the investor profile. So all this requires, so these are the examples that we are already seeing, which companies are trying to build, because they're trying to differentiate themselves. They want to give a better user experience to the user, better, experience or better service to their customers. So let's look at, let's briefly look at, what artificial intelligence really means. So if you go out and if you go out to Google and try to search about artificial intelligence, you will come across something like this. So there is the AI community or the researchers or all the people involved. So they have come to some sort of a consensus that we can look at artificial intelligence in 3 different maturity stages. The first one is a narrow AI. What it means is intelligence which occurs only in a limited scope. or narrow domain or a specific domain, a problem space. Then comes general AI, and then super AI. So let me start from the right-hand side, which is a super AI. So this is the stuff of sci-fi movies. So all the movies that we have seen about where the machines take over the humans, and they have intelligence or capabilities much more beyond the humans. So that is the stuff of that is something which is categorized as super AI. Then comes general AI. General AI is something where the system will be able to perform broad tasks. So for example, the knowledge which is obtained from one domain can easily be applied to another domain. And the third one, narrow AI, is whether the system is able to do things intelligently in a very specific domain or in a very, very narrow domain. So actually all the examples that we see, even the system that my previous speaker talked about, she mentioned that it is in a specific domain of e-commerce. So that and all these are examples of narrow AI. So we haven't actually, there has not been any demonstration of general AI till now yet. Even your IBM Watson or DeepMind, which is a Google company, AlphaGo, which has beaten the best player of AlphaGo in the world, even those are examples of weak AI. Because the DeepMind, let's say, cannot be applied to play chess, for that matter, or to maybe some variation of that game. Even Sophia robot that we see, and it is it appears to be an intelligent human that you're talking to, but even that is an example of a weak AI. So these are the kind of systems that we are going to encounter in near future, which will all be examples of weak or narrow AI. So, for example, systems like recommendation system or chatbots, or virtual assistants like Google Home, Alexa, or robots. So these are all examples of weak or narrow AI. And weak or narrow AI is the one which is actually leading to all the automation that we see in the world. Because the weak and narrow AI goes deep, and it is so good at doing certain things, certain specific things so well, that it is eliminating presence of humans from those fields. So this is the entire spectrum of artificial intelligence. If you go, so this is the entire spectrum that the artificial intelligence could manifest in. For example, machine learning, natural language processing, speech, expert systems, planning, robotics, vision. So this is the entire spectrum. Machine learning, which is the most common one that we hear, is right there, and a subset of it, which is a deep learning. Right? So machine learning, so for example, there's a lot of, let me go to the next slide, and then it will be clear. So we take machine learning, deep learning, or AI, we take these names or these terms in same breath. But what actually artificial intelligence is? Basically, it is some level of achievement where we can, the system can sense, reason, act, and adapt. Once we achieve that, then we can say that we have achieved artificial intelligence. Machine learning is one of the approaches of achieving artificial intelligence. So machine learning could be, it's basically, it's an algorithm whose performance improves as they are exposed to more and more data. So what it means is, the system is able to learn and better itself as we feed more and more data to it, we train it, and that is how it evolves. Deep learning is even a subset of, or it's actually an approach to do machine learning. It's one of the techniques to achieve machine learning. Let me go to next slide, and then it will be clear. So machine learning is basically where, so machine learning is something, where the humans who are called upon to build the system, so they do a lot of pre-analysis beforehand, and then they feed it to an algorithm to come up with a model of the underlying space, problem space, and then which leads to a result. Deep learning is something where the two things, so there is not a lot of upfront preparation, but there is, the features, or basically learning from the underlying problem space and really come up with conclusions about it is something that is ingrained, it happens together. So deep learning is something which is driven mostly by a neural network, which is like how our brain works. So we are fed all the sights and sounds and smells and everything, and we conjure up, we create our own understanding of the environment around us. So deep learning is more akin to that. Machine learning is more controlled in the sense that it is humans or the people who are working upon that system. They do a lot of pre-analysis, feed in the data, train it, do those iterations, and eventually come up with an intelligent system. Even machine learning or deep learning are examples where it is. You can also say that they are not explicitly coded. So whatever is the underlying problem space, for example, it could be an e-commerce system or a recommendation system. For example, let's take a recommendation system. So there is no explicit coding that because it is not really possible, because the problem space or the diversity of users is so large, you can't really have a rule-based system which will identify all the possible combinations and recommend the right thing to the particular category. So it is something that can't really be explicitly coded. Now let's look at what is so on one hand we are trying to build intelligent systems. So what are the conventional systems? So conventional systems are the ones which we already have, which we are testing or which we are building or testing day in and day out. So I put a flow chart there to emphasize on the fact that however big that conventional system may be, for example, a large banking operation system or a e-commerce system, it is explicitly coded. It might have taken an army of people years together to build that, to come up with that system, but it is explicitly coded, it is there. Somebody can reason about it. If somebody asks you, why this thing is working like this? So you can really go back to code or maybe the specifications and you can reason about it that this is how it is working. The machine learning model, you can't really reason because there is no step-by-step logical reasoning for it. It just works. So conventional system is what we mostly encounter with. So these are the characteristics of a conventional system, that it is explicitly coded, they are stateful. The number of states of the system could be enormous. It is like the database can be said that, this is the state of the system. Now one important thing, as long as the state is frozen, same inputs would result in same output. This is what we do, right? We take production, dump of production, if let's say there's a bug in production, if we want to replicate it, what we do is we take the production database, put it in our testing database, carry out the same steps, and it leads to the bug, and we are able to replicate it. So that's why we can make a statement that functionality, I'm only talking about the functional requirements of functionality of a conventional system, is deterministic. You can always determine. You can go back to the specifications, or you can try to replicate whatever defects or issues which have been reported, and it is deterministic that you will arrive at the same result that somebody else is observing. So that is deterministic, then it is possible to have test oracles, because specification is given. We also are, we humans who, we testers who work on it, so we can come to know, okay, what is expected. Or, through some heuristic or some mechanism, we can come up with, okay, this is what is expected, so that we can compare it against the actual. In fact, even conventional systems, so, our view of looking at systems is something which is machine is doing. If we club the maintainers of, builders and maintainers of that conventional system together to an external observer, they are actually intelligent system, right? Artificial intelligence or the notion of artificial intelligence doesn't make a difference between how that is achieved. As long as you are able to sense, reason, act and adapt, you are intelligent. So that can even be achieved in a conventional manner. Right. So in fact, so there is no slide about it. So there is something called as AI effect. So actually, the way people look at intelligent system is the moment it is achieved. For example, IBM's Deep Blue, when it beat Garry Kasparov. So they have actually started discounting it as really intelligent, because this is something which is achieved. So there's something called as AI effect, which means that anything which has not been done yet is artificial intelligence. So that's a kind of a notion which floats in the industry, that okay, for example, Alexa or chatbot. So we are in the technology field, we know how they're developed and built, but people at large, now that it is so proliferated, though they really discount the amount of effort which has gone in to make them that to the stage where they are. So they don't really call it as artificially intelligent. So we looked at conventional system. Let's look at a machine learning system. So here the most important thing is the learning algorithm. So basically, the machine learning process is that you first of all make it available all the data which is on the left hand side, and then at the core of it is a learning algorithm, which is then trained again and again to come up with a model to, let's say, predict something or classify something, and then embed it in a part of your offering, which is a application, let's say web application, where you can embed your recommendations, and then that is offered to the customer for a better user experience. So learning algorithm is trained and a model is developed, which is approximation of underlying problem space. Humans are integral part of learning. So they provide data, learning algorithm, measuring performance before it is put out. So it is not as if that intelligent system come out of blue, come out of the blue. They are really, there's a lot of hard work which goes into to develop them. As more and more data is provided, the system improves itself. However, here's the difference between conventional system and machine learning system, that same input at different stages of training could yield different output even if state of system is frozen. So what happens is the algorithm or the model which has been trained, if let's say you come back and feed it the same input, or let's say for example recommendation system where the user's profile are already, so whatever the user profile were there at that time, you feed in the same thing, it may not recommend you the same thing. It might recommend something very specific or maybe a wayward. So it is not really possible to have test oracles for intelligent system. And we can say that functionality of a machine learning system is non-deterministic. So please keep in mind that this is a functionality. What is the functionality of a machine learning system? It could be used to predict something or classify something, right? So that aspect is non-deterministic. compare that to conventional system. The functionality, for example, you input some value and this is the output that you are supposed to receive. That is deterministic. Now, so these are just basics. So there are three types of machine learning. The third is missing here, supervised, unsupervised, which helps us in classification, regression, clustering. So this is the challenge of testing intelligent systems, that the non-deterministic aspect or the approximation nature of the intelligent system. So that is the problem. That is the challenge that we have. Now let's go back before so as I said in agenda that I'll make some claim. Before that, let's go and brush up on some of our basics. So what does software quality mean? In fact, I could not articulate it myself, so I had to look up Wikipedia, which is the link I've given. So broadly, it can be divided into functional and non-functional aspects. Functional, whether the system complies or conforms to a given design based on functional requirements or specification. Second is the structural quality of how it meets non-functional requirements that supports the delivery of functionality or functional requirements, such as performance or reliability. Clear? So we have functional aspects and there are non-functional aspects like performance, reliability, usability, this, that, all the abilities. So these are those list of non-functional quality attributes. So I have clearly marked out a couple of them, which is effectiveness and accuracy. So this is something that we might be, this might connote to, let's say, an intelligent system, that how effective or accurate it is. Now what is testability? Testability is whether we are able to control our tests, control our experiments. So testing is like an experiment. The way we did science experiment, we do an experiment, whether we can control it, all the conditions. Then whether we can, once the experiment has been performed, whether we are able to observe and whether there is availability of test oracles, which can tell us, okay, what is really expected out of that experiment. This is about testability. So what I'm saying is the testing of non-functional attributes is, I'll come to the conclusion later, but so when we are really testing for non-functional attributes like performance, usability, so the system which is under test, for example, you have a web application with performance where you're trying to test performance, security, or usability, or any other abilities. It is not something that is beyond your control, because your system is a system of systems. You have only coded the web application, which you might have done in whatever web application framework. But it is running inside a browser, it is behind the internet, because it is being served from this, this internet, there is the infrastructure on which that application is running, which is the cloud VM, OSs, networking, all those stuff. So what happens is the testability of systems reduced to the extent that the quality of non-functional aspects become non-deterministic. So you are getting the point that you can't really test all those non-functional aspects, because it is really whatever the user is going to experience is really built out of a system of systems, and the only control that you have is on your application, not the rest of the stuff. So non-functional quality is perceptible or experiential. This is something like, for example, we experience a good performing web application. We experience security when dealing with doing any transaction on web-based application. We experience intuitive user interface, right? This is something which is experiential. It is not something which can be given us as an informative that, okay, this is highly usable. It is something that user will experience. So we can never be 100% sure. So what I want to conclude is, testing of non-functional attributes is also non-deterministic. Right? So 3 things we have, means I am claiming that functionality of conventional system is deterministic. Functionality of intelligent system is non-deterministic, and non-functional attributes, so testing of non-functional attributes, or basically non-functional aspects of a system, is also non-deterministic. So the claim which I am making is, the testing of any intelligent system is equivalent to testing for non-functional attributes even of a conventional system. Again, let me repeat it. So testing of intelligent systems is equivalent to testing of non-functional aspects or attributes even of a conventional system. So that is one claim which I wanted to make, and one. Now let's look at how testing of a non-deterministic system can be carried out, or the kind of approach that we need to have while testing for non-deterministic aspects or non-deterministic system. So inherent difference, which you might have noted if you guys have tested for non-functional attributes, and for example, while doing performance or security, my experience has been it never gets done fully. Because the mindset or the approach with which we approach testing of non-functional attributes cannot be the same as the mindset or approach that you have while testing functionality of a conventional system. So let's look at it this way. So conventional system, as we saw, that it can be explicitly coded, however long it may take or how many people it may take, but it can be explicitly coded. So your development or product owner, stakeholders will make sure that whatever they're coding, they have absolute all the information that all the rules and everything that they have. So a tester can take a destructive or an adversarial approach while testing for functionality of conventional systems, because his counterpart would have already taken care of everything, because all the rules, theoretically, they are all deterministic. You can explicitly code, okay, these are the rules. For example, this is how the transaction should happen. This is how for example, e-commerce. So this is how the cart is going to be populated. This is how the transaction has to happen, and things like that. So everything is determined, and that is what the development team or it is supposed to explicitly code. And we take approach that, okay, fine, you have done your job. Let me do now my job, which is to find loopholes or defects or bugs or try to break the system. That is the approach that we take, adversarial. However, the same cannot be done for a non-deterministic situation or system. So there, the tester or the QA tester's role has to be constructive. What it means is, rather than bringing down the system or try to bring down the system, you help build the system. Now let's see how it can be done for an intelligent system. So this is what I said, that QA test professional has to play constructive role in building an intelligent system rather than a destructive role in a conventional system. So let's say this is how a typical machine learning system is built. Very high level. First stage is data preparation. Second is feature engineering. Third is data modeling. Fourth is performance measure. So after doing this over and over, you really perfect your model. What does data preparation mean? So it means whatever is your underlying problem space, you gather all the data, right? It could be, for example, for banking or e-commerce, let's say all the transactions. Then there are a whole lot of other things that you have to do, like cleaning of data, sanitizing of data, removing the outliers, or this actually falls in the data engineering aspects. So this is more like a data engineer or ETL step. Do you think that QA or test professional can contribute in this stage? Yes, they can. Because we as QA test professional, we already deal with data, we do automations. Feature engineering. So what is feature engineering? So it is a process of transforming a raw data into features that better represent the underlying problem, so that our model is improved, its accuracy on unseen data. So for example, let's say you want to build Magicbricks or some other real estate company. So the application that they're building, so they want to build a prediction system or a prediction system for price of the housing, of the houses. So you'll very quickly, because all of us, let's say some of us own a home and we have done all the R&D, so we know that okay, certain things are very directly impact the price of a house. So what would be those features would be? So size, floor, locality, right? So these are very, very clear. We don't really need any any expertise for that. But what about other aspects? For example, its proximity to other public utilities. If we look at further, how, for example, the utilities could be a train station, bus station, airport, schools, and everything. But how even the proximity of those public utilities would be in consideration for the prospective buyers? It becomes really difficult to start fathoming what are the factors at play which are going to affect the pricing for a house. Okay, so this is a step which requires a deep domain expertise, because there are so many factors or features which are at play, and sometimes factors at play, just discussing in the air is not enough. We somehow have to transform that in the form of data which can be fed to our training. So typically the steps for feature engineering would be brainstorming a feature, create, how it is working with the model, and basically iterate. So I have written this in a layman's language. It is a very involved thing. Right. So do you think this step can be done by QA test professionals? Very much, because we as QA and test professionals, so we have the deep expertise or deep knowledge of the domain, or basically the knowledge of the underlying problem space, because we are the ones who have been a representation of the users who are going to really use the system. We are the ones whose role is broad-based, apart from, let's say, product owner or stakeholders, right? So QA test professional can very well contribute in this stage. Next step is data modeling. So this is something which is esoteric. This is something which is the most in demand. This is something which most people aspire to become data scientists, who will put on their research. So this is a stage which requires a lot of understanding, a lot of mathematics, statistics, and all other techniques that we have for data scientists. So this is, maybe we can we can skip this one. And last stage was performance measure. So these are some of the ways you can measure the performance of your machine learning model or intelligent system. These are more mathematical and statistical in nature. You can read the names and you can figure out, okay, we are trying to give some sort of a score or figure to the deviation it has from what is expected. However, let's look at the other approaches. What are the other performance measures for intelligent system or a machine learning system? So they are, you can do, let's say, testing by end users or crowd testing, because that can give you confidence. Then you can come up with equivalence classes or the boundaries of what is expected, because it is non-deterministic. You don't really have an expected value, but you can always come up with a boundary. Or you can always, boundary. So again, that is something that comes through experience. Instead of passing or failing a test while testing for a functionality of an intelligent system, we can rank it. Instead of just 0 or 1, whether that can be done in a deterministic system, but not really in a non-deterministic system. You can rank it like 1 to n. And finally, you can even do a comparison test. So let's say that underlying problem space already have one of your competitors who has already built something intelligent. You can go and compare yourself with that particular system. So do you think this is something that QA test professionals can do? Right? Very much? Right. So what we see is that out of those 4 stages of building an intelligent system, at least in 3 of them, we QA test professional can really contribute. Data preparation, feature engineering, performance measure. And that is where I wish to say that, by doing all this, like feature engineering or data preparation, you are actually helping, you are playing a constructive role in building that intelligent system. Even while doing performance measure, you are actually helping build that intelligent system, and where your approach is constructive rather than destructive, that okay, you are sitting waiting for that system to come up and break it. All right. So let's look at what could be the skills for let's say, machine learning, or it could be intelligent system QA test automation engineer. So it would definitely involve everything that whatever skills that a typical QA test professional needs to have, which is critical thinking, articulation, and rest of the others. So these are the more qualitative and whatever other skills that you have. On top of that, what you need is an academic or learning mindset, because the kind of system that you're building itself is learning and it is adapting. So you as a test engineer, QA test engineer, has to let go of that rigidity and be ready for learning along with the system or the model. Then you need to understand machine learning methodology except data science. Let's leave that to all that is esoteric, let's leave that for others. Bit of maths, probability, statistics, then business domain expertise, especially user behavior and factors in play. This is what we covered in feature engineering. So this is something which is, I believe, we as QA test professional, if we are really doing justice to our professional, are already there. So intelligent system, will be built out of the domains. The problem space is not going to be new completely. They are going to come from ordinary lives. So for example, e-commerce was already there. Recommendations came later. Right? Then the last 2 things are a little, they are just technical, and they can be, probably they're equivalent to what, for example, if you want to do test automation, we need to learn a lot of tools and programming and everything. So similarly, we need to learn some ML tools like Python or the data science or ML modules, a little bit of expertise on data. So my proposition is, if we evolve, or the QA test professionals evolve themselves and equip themselves with these skills, they can play a very important role in building of intelligent systems, and not just be there to test the conventional part of the intelligent system, right? So what can we do before we encounter any intelligent system? So it is something which is happening in niche. It may start growing, like more and more people will jump on the bandwagon. But it's not necessary that all of us are going to immediately be put on in testing functionality of an intelligent system. So what can we do till then? So remember, I told you the equivalence of testing for non-functional attributes of a conventional system is equivalent to testing for functionality of an intelligent system. So at least what you can do is start testing for non-functional attributes like performance, usability, reliability, and all other abilities in whichever domain that you are, to really gain that mindset, because there also you have to be constructive. For example, for performance, you can't really be sure whether how, when the software is deployed, what state it will attain, and whether the performance really will be a good user experience for the user. So there's a lot of iterations, there's a lot of collaboration that you will have to do with your team, your development team, product owners, and stakeholders. So my advice would be to practice that till you encounter any intelligent system or a machine learning system, and try to test non-functional attributes. Right, so this was one aspect. So basically here, till now, what I've talked about is how QA or test professionals can evolve themselves to the testing of intelligent system, which are the rage. In fact, I'll have a slide there towards the end, which is to circle back onto the theme of the conference, which is, the theme is IoT, big data, AI. IoT is going to feed into big data is going to feed into AI. All the IoT has its other applications, but one of the applications is to collect data, large amount of data. Then big data technologies are to process and make it, they are all about crunching all those big data, storing, ingesting, keeping track, and doing all the processing, which is meant to eventually feed into intelligent systems, to train them. So that is where it is all going. So till now I was talking about how QA test professional can evolve to test such systems. Intelligent testing is all about how QA test professional can utilize the power of AI, ML, DL, or whatever aspects of artificial intelligence for their own, to benefit them. It could be even for conventional systems. So for example, my previous speaker, she talked about the system that her company has made, which is going to help testers, or which is going to help testers, or you can say, so she put it very controversially that it might even make us redundant, but as long as there is value that we are adding, so we'll always be there. So it can help, we can utilize it for our benefit, and be more productive with our work. So these are the areas where AI, ML for testing purposes could be we can look at, here again, so most of the, for example, the previous speaker, the system that she mentioned, or the ones which are, I have a few listed in my next slide. So they are there, but it is still a nascent field. It's a nascent stage. It is still weak AI. It is not easy for, taking the intelligence system which is working well in one domain and take it to another domain as it is. So we have to play a part in that. We have to contribute towards embrace these technologies, AI, ML, DL, or all these vendors who are trying to try them, and see how they can help you reduce some of your efforts, so that you can be more productive. You can add more value in the entire journey of your product. So these are the areas where AML could help. So one is the test automation, which is to author automated tests, self-healing automated tests. So one of the main thing which occupy is to maintain our test suites, where something is broken, this and that flaky test. AML, which is well trained to, let's say, to identify that, okay, this is really because of this reason. Maybe we can come up with auto-healing automated tests. Similarly, generation of API tests. So API is very well defined. It is very well documented. The clear interfaces. We can very well come up with API test suites. API testing, visual inspection of UI. So for example, whether application where the rendering of application is one of the crucial aspects. So we can use visual inspection tools. Yeah.
Can you give me a use case of AI/ML for API?
So for example, you have your API which is well defined. REST APIs, for example. So you can, and let's say there is an intelligent system which is already has seen, or it has been trained on a number of systems which have well-defined APIs, and it can start coming up with all sorts of combinations which are prevalent in, let's say, using those APIs. For example, a web application is built on top of REST API. So you can have a set of APIs. So REST API is like so it's like a CRUD operations that you do on entity using HTTP. So all sort of combinations which have been, so that system is going to be trained on a number of systems or APIs, and then you can apply it to the system under test to come up or generate tests.
So can a recommendation engine of my Amazon app be under this category?
Yeah, so it is similar in nature. So it is something which is similar, because if you look at very well, so for example, so it can recommend, for example, so that system has been trained on the number of systems with the APIs, and if there is something which you have missed out in while coming with the tests for your APIs, so it can recommend that why don't you try this combination. Similarly for test cases, so this is something which I have not seen. This is something which I have not seen, but these are all the possibilities. In fact, one of the vendors I was searching, like, is there already a, let's say, a case study or something about automatically generating API tests? So I saw one vendor which is claiming that they have a automatic API test generation, so which is mentioned in the next one, and which we can try. So this is something which I have not seen, but taking a cue from the kind of recommendation system we have already in place. See, so all these technologies are being.
Because API testing, when you do it, is more specific to the web service or the specific API render test, and getting a branch structure out of it to test as part of recommendation, it would be slightly illogical, maybe or may not be. Could be a question.
So actually, ideally.
Use case would be really helpful to understand where it could be.
Right. So ideally, what it would be that. So what I've seen is the APIs which are being developed, not all of them are actually are not used, because you don't really. So for example, a lot of APIs are developed for consumption, not just internal client but even external client. how those external clients are going to be using. So for example, you can, let's say, put some sort of a recorder of how your external clients are using and generate, okay, these are, different forms in which they are using. So that becomes a test data for, feeding to make that system learn. And then you can, in all that learning, let's say, for example, the e-commerce example she gave, that 80, 90 retailers, they have already trained. So similarly, if we can train hundreds of systems which have API developed and how their external clients have been using, or internal or external clients have been using, and train that system, and then we can apply that to our API that we are developing, and which can recommend some of the missing combinations. So that is something which is possible. What I'm saying is it is all possible. Defect analytics, another area. So these are some of the vendors which are already doing it. For test automation, Mabel, Testim, Test.ai, Applitools, Parasoft is the one which is for API testing. Which means I have not tried it to that extent, but it is there. And there are service offerings from AIML driven testing from Infosys Accenture. So this brings to the end of my presentation. So basically the two things which I established is, one, that how QA or testers can evolve to test intelligent systems. Second is how they can utilize the power of AIML to build tools or to demand for such tools from the industry, which is going to help them do their job better.